Welcome back. Today we're going to talk about factorization. In this Mathematica tutorial, we're going to learn about how to factorize an algebraic expression. This is a very important skill for people learning algebra and, going on to do other more advanced things, calculus, etc. So it's very important. I suggest that you get a solid understanding of this. Okay, so we'll start with expansion. All right, so let's have a look at what I've got right here. A times B plus C. All right, now there's a rule that says we can distribute multiplication over addition. All right, and when you do that, the A gets multiplied with the B and adds to A times C. All right, just like this. Now, all of you are probably familiar with how this works with numbers. So you have 2 times, in brackets, 3 plus 4. Now, what that means is that you have a choice of how you want to view that. You can view that as 2 times 7, which is the sum of 3 and 4, or you can view it as 2 times 3 plus 2 times 4. All right? They're both equal. All right, and that's the beauty of multiplication distributing over addition. Okay, let's have a look. Here you can see I was playing around with some of the Wolfram Alpha features. All right, but I'll scroll down and we'll talk about this exact calculation in Mathematica. All right, so I'll go 2 times 3 plus 4. All right, so we know this is 14. So shift enter and get 14. All right, now is that indeed the same as 2 times 3 plus 2 times 4? Now you notice sometimes I put the asterisks and sometimes I don't. Well, that's just a matter of choice. Sometimes it's really more clear when you put in the asterisks. Okay, anyway, let's shift enter. Both 14, sure. So that's exactly what we're doing. Now let's do this with letters, okay? So A, B plus C. If I just do this and shift enter, well, it should. Oh, I know what's the problem. The last video I did was all about music, okay? So I've got things in memory and I must now go and abort the evaluation and clear the memory, okay? So sometimes when you press abort evaluation, it takes too long, right? So sometimes what I do is simply quit kernel. Go down here and scroll, quit kernel local. Okay, and that forgets everything. All right, so you come back and start it up again by pressing shift and enter. Okay, shift enter. The first time it's quite slow because it's starting up the kernel. All right, and there it is entered, and the second time it's fast. So fast that you can't even see the calculation happening. All right, so what I was saying is that if we put A in brackets B plus C as in to multiply that product, well, it will just give me back simply the same expression. All right, so what I have to do is if I want to expand that and get AB plus AC, well, I simply write expand. Okay. Expand, shift enter, and now Mathematica will return AB plus AC. All right, so let's take this now. Now I can just press enter after it and it will turn it blue, right, telling me that I now have a symbolic expression, but it's opened up a new cell in that way. So how do you go backwards in Mathematica? All right, in other words, factorization. So you just write factor. And now you press shift and enter, okay? Shift enter, and we get back the original expression A times B plus C. All right, but how would you do this by hand? Well, you look for what is common that you can pull out of it, okay? What do we have common in this expression? There's an A here in the first one, there's an A here in the second one, and the assumption is that B and C have no common divisors. Let's just treat them as algebraic entities. So we take out what is common, all right? In this case, what is common is the two A's. They're common, and so they can be factorized out. Okay, so that is what factorization is all about. Expressing something in terms of, say, a sum, and expressing it in terms of a product. Okay, so let's have a look at what else we have to say in my booklet, a YouTube course in Mathematica. So this says, given a sum of terms, we try to find a way to rewrite the sum as a product involving brackets. So we're looking for a common factor, an expression that divides into each of the terms and that goes outside the brackets. Right now we have an example here. So I'll scroll down in my booklet, have a look at this example. And let's see if we can repeat some of these calculations here. All right, so first of all, we are to factorize, as an example, 3x squared plus 6x. So what we do if we're looking for how to do this by hand, okay, if you're just learning, that's an important part of the process. So look, 3 and 6 have a common divisor. That common divisor is 3, all right? 3 goes into 3, and 3 goes into 6. Okay, so we know straight away that 3 is something we can factor out. Now, there are also some common x. Right, the first term has an x squared. The second term has a single x. Right, so one of those x's are common that we can factorize out. So we should be able to factorize out 3 times x. Then we look at what remains. Okay, so if we take 3x out of the first term, what remains is a single x. If we take 3x out of the second term, what remains is 2. So we do this, we express this as 3x times x plus 3x times 2, and then we take out what is common, in this case 3x, and then we write the other multiplicand is what's left over, so x plus 2. Right, and that is the expression factorized completely. Okay, so now you want to be able to check your work in Mathematica or Wolfram Alpha. So how do you do that? Okay, that's easy. You just write factor. And then I'll enter the expression. So I'm leaving a space here because you can do that in Mathematica to mean multiplication. All right, so this is how you enter 3x squared. And then plus 6 space, which is to say times x. Okay, shift enter and we should get 3x times x plus 2. All right, and Mathematica likes to write this in reverse, like you would have if you're dealing with the Taylor series, where the higher powers are to the right, okay? But most of us, when we write it by hand, we like to put the higher powers in the front. Okay, both are okay. Okay, so that's how you do this in Wolfram Alpha or Mathematica. All right, now let's look at a slightly more involved calculation. Well, look, we've got a 2 in the 2, we've got a 2 in the 8, because 8 is divisible by 2, and 14 is also even. So we can factorize out 2 from each of these terms. All right, what about the letters? Okay, we have a B common, there, and there. Now, I don't see any other letters that can be factorized out, so in this case, we should be able to factorize out 2B. Okay, what remains? Well, an A, a 4, and a 7C. Just looking at that by inspection. Now let's check this in Mathematica. So we say factor, then I'll enter the expression 2AB plus 8B plus 14BC. All right, factor, shift enter, and it does just exactly what we said. Okay, now let's have a look down here. There's another one. Well, this one seems to me to be irreducible. All right, but let's just double check that using Mathematica. So I'll write factor 3xy plus 6y plus 2x plus 4. Right, now this should be irreducible because the greatest common divisor of 3 and 4 is 1. In other words, those two are relatively prime, meaning their GCD is equal to 1. All All right, now notice this 4 doesn't have an x or a y next to it. Okay, so if we're to factorize something out, we'd have to be able to pull it out of the 4, but we can't pull it out of the 4 and pull it out of the 3xy or the 6y as well. Right, we've got to pull it out of each of the 4 terms here. Okay, so this is what we call irreducible. In other words, the factorization is just the same expression. So I'll press Shift Enter. What? Okay, we all make mistakes, so let's have another look at this. Let's have another look at this. Okay, so, yeah. Right, so if... How do I explain this? Okay, so if I expand what's in the brackets here, what it gave me, I have 2 times 2, which is 4. I have x times 3y, which is 3xy. Then I have 2x. Then I have 2 times 3y. All right, so when you multiply such a thing out, you have 4 terms. Okay, this goes with this. This goes with this. This goes with this, and this x goes with this 3y. All right, so how do you recognize that from this expression? All right, so let's have a look at that by hand. Now, we already know what Mathematica gave us. It corrected me. So how do we see this by hand? All right, so you do it a piece at a time. You say, well, look, in terms of the x's, I can factorize from the 2 expressions that have an x in it. I can pull the x out. All right, so let's do this by hand a little bit at a time to see how we can get this factorized expression. Okay, so we first have this. All right, now I'm writing a hand calculation, and so I'm going to write in comment form. So not in code, just in comment form. So I'm going to put equals equals in case I accidentally press execute. Okay, now what are we doing? I'm first of all rearranging this. Haste makes waste, huh? Okay, so I want to put the x's together, and now I can see what's common in this part of it. Okay, so I'll go through and write another line. Now, what I'm doing in the first place is factorizing the x out of this the first part, the part that has the x's in it. So I'll put a bracket, and then I'll write the x there, and I'll pull the x out at the same time. Okay, now that is factorized, right? Let's do the same with the this other part of it. So I can pull out a 2 because the 2 is common with the 6. All right, so I'll put a bracket. Okay, and now I'm pulling out a 2, so I'll put 3, what remains there, and the 2 remains there. Okay, now look, these 2, we can see that they are common. Okay, so let's come down, copy this, and I'll go down to a new line, so my body is not in the way. And now we can see that 3y plus 2 is common in both of those terms. All right, so I'll put a bracket around this, and then I will copy this, copy, paste it there, get rid of it here. All right, and there we have what Mathematica originally gave me, which is not what I first saw. Okay, so look, we all make mistakes. Okay, I'm not gonna edit that out. All right, now let's turn this into a comment. Okay, so I'll put a bracket and asterisk. I'll come down here and do the same. Asterisk, bracket. Now it's a comment. So within the same cell, I can run some code. All right, so what I want to run is expand 3y plus 2 times x plus 2. All right, come out and shift enter. And then we get the original algebraic expression that we started with. Okay, so that's good. That means you are able to check your calculations. It's very important because when you're learning about this, you can miss something, make a mistake, but Mathematica or even Wolfram Alpha brilliant at getting it always right. Okay, at least in these cases. Okay, so yeah, that's how to expand. Now we could also factorize it, and we've already done that, so good. In summary, Mathematica can help you check your work. All right, and here I have the calculation written out, so I should have seen that first. Okay, next one, expand this expression. Well, look, you just press right expand and expand it, and you'll get the result. But let's talk about this by hand. Okay, so the x goes with the y. Now we've got 1, 2, 3, 4 terms here. When we expand, we're going to get 4. The x with the y, the x with the 4, the minus 3 with the y, and the minus 3 with the 4. Okay, so now, anyway, this is the calculation expanded. Come back and go to the cell. Okay, now there are some fancier things that you should learn, all right? One is perfect squares. So if you see something of this form, a squared plus 2ab plus b squared, well, know that you can factorize that as a plus b times a plus b, right? Because you notice if you expand it, well, you get a squared plus 2ab plus b squared, all right? And you can write that as a plus b all squared. Now, for example, if you look at this, x squared plus 4x plus 4, well, you can view that as a perfect square, all right? Because you would set a equals x and b equals 2, and then you can view it in this way and factorize it as x plus 2 all squared. Okay, so let's scroll down a little bit. We also have a difference of two squares, which you should also remember. Right, a squared minus 2ab plus b squared is a minus b all squared. Right, for example, x squared minus 6x plus 9 is x minus 3 all squared. And you can recognize that by putting x equals a and b equals 3. Okay, so let's have a look down here. Difference of two squares. That's the third important thing to memorize when you're thinking about and learning about factorization. A squared minus b squared can be factorized as a difference of two squares. Okay, so a plus b times a minus b is equal to a squared minus b squared. And that's useful. For example, x squared minus 49, notice that 49 is 7 squared. Right, so we can factorize that as x plus 7 times x minus 7. Okay, likewise, x squared minus 1. 1 is a perfect square, it's 1 squared. So we have x plus 1 times x minus 1. And again, 4x squared is a perfect square. 25 is a perfect square, so this is a difference of two squares. We have 2x all squared minus 5 squared. And so we can write that as 2x plus 5 times 2x minus 5. Okay, that brings us to discuss quadratic polynomials. How do we factorize them? Well, by hand, it's good to know how to complete the square. So I'm going to open up this Mathematica notebook and show you the process of completing the square. All right, so first of all, I will write ax squared plus bx plus c. Right, so this is, well, I don't want to get ahead of myself. I'll just talk about completing the square. Okay, so what I want to do is view this in terms of a perfect square. Okay, so look, let's, first of all, I think what I want to do is say y equals this. Okay, if I have y equals this, and now what I'm doing is writing in comment form again. Okay, so why is that? Now, our first step is to multiply throughout by 4 times a. All right, so we'll write multiply by 4a. All right, so doing so, we have, I'll just copy, paste. We have 4a y And then on the right hand side, this is equal to 4a times a plus 4a times b plus 4a times c. All right, now look, we've got two a's multiplying together, so that's actually a squared. Okay, so we have gotten this far. Look, you know what? I'm going to take off this comment because I want this to be more colorful and less turquoise. Okay, so what are we doing next? Now, I'll copy this. What I want to do is look at this first part of it as something almost a perfect square. All right, so what would I have to do to this first part of the right-hand side here on the left of the right-hand side in order to make that look like a perfect square? Right, so notice that it's almost, well, it would be so if I just had a plus b squared there, right? Right, so let's add that, but if we're going to make this correct, got to subtract it also. All right, because b squared minus b squared is 0, so I've really done nothing. Okay, but now I want to put a bracket around this, right? And that I am permitted to do because we have associativity of addition. Okay, now that we have this here in the bracket is a perfect square. Okay, so I'll copy this and come down to a new line. Now, what is this? First term here is 4a squared x squared, but that is 2a x all squared, all right? So I know, all right, so I'll write 2ax and then plus something else, and I'll straight away put my square there. Now I'm looking for what else I need. All right, b squared, that's a perfect square, it's just b all squared. Okay, now, is this what I want? All right, notice that this squared is this squared is this. What happens when I multiply this by this and I do that and add it to itself? All right, well, I get 2abx plus 2abx, which is 4abx. Okay, so it's exactly correct. 2ax plus b all squared is this. All right, so that's completing the square, right? We have a perfect square plus something else. Right, so how can I use that to find a factorization? Right, well, what if instead of y here I had 0? Okay, so I'll write if y equals 0 and I want to solve the equation. This is 0, not 90, 0. Okay, well, what do? I can use this. I can use this fact right here. I'll say then this is 0. Okay? And now rearranging this equation, I can take this minus b squared plus 4ac over to the right-hand side of the equation. All right, so let's do that. So I'll say so. And then if I do that, I must have, on the other side, I must have a b squared minus 4ac. Okay, so right here we are. Now, if I take square roots, well, I get plus or minus the square root of the right-hand side because I'm solving for this. For the moment, you might view it as z squared, and if I'm solving for z, well, I get plus or minus the square root of this thing on the right. Okay, so let's say we have 2a x plus b is equal to plus or minus, I'll just write it like that, plus or minus, and I'll write out sqrt for the square root, b squared minus 4ac. All right, so we have that. Now think about this. We're trying to solve this equation for x. Okay, so what we do next is we subtract b from both sides. So minus b. Okay, and I'll remove that. And finally, we want to divide both sides by 2a to solve for x. All right, so I'll come down and say, finally, x is equal to, well, I got a phone call, so I better answer this. Hello, Sam speaking. All right, are we still there? Well, that was a phone call. So it looks like I'm going to be marking some exams, so that's good news for me. Money is great. Anyway, where were we? We were dividing throughout by 2a. So I'll put a bracket around that. 2a. And wow, you know what? This hat backwards is not so professional, so I'll take it off. Spruce up my hair. All right, so what did we have in the numerator? This one. All right, so what have we done here? We've solved for x, and what we've found is what's called the quadratic formula. All right, which a lot of people memorize, and it's a great idea to memorize that. All right, you can maybe even think of it a bit like a song. I don't know how they do that, but so it's minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now this inside the square root, we call that the discriminant. All right, so sometimes we use an uppercase delta to refer to this, right? Because the sign of this discriminant is very important. If it's positive, then we have two real roots, because this is a number and we have a plus or minus, so that gives two things, right? If we have a zero discriminant, well, we only get one, right? Because we're looking at plus or minus one, sorry, plus or minus 0. So the only real root is minus b over 2a. Now some people would say that there are really two there in that case because it's just repeated. It's a good way to think of that, because then what you call the fundamental theorem of algebra is very useful. You always have as many as the degree, as many roots as the degree, provided you're willing to think of those roots in an abstract way. All right, so if you have b squared minus 4ac is negative, well, then you still have two roots, they're just not real, okay? You get what we call a complex collection of solutions to this equation. Okay, so that's solving this. Now, going back, how does this help you factorize? Okay, how does this help you factorize such an expression? Okay, well, I've gone back to this expression that we found up here to talk about the factorization of this one. All right, so what I want to do is put a bracket around this, and I want to view this as the square root all squared. Okay, so I'll put SQRT squared. All right, so now I'll subtract that from both sides. Is 0, okay, and now I can use what we learned earlier, that we have a difference of two squares. All right, and that tells us the factorization of this expression almost. Okay, so let's do that. Use the fact that we have the difference of two squares can be written as a product. So we have 2ax plus b, and then we have plus the square root of the discriminant. Okay, and then we have almost the same thing, except we replace the plus in the middle with a minus. Okay, now we have a factorization of this expression. All right, but when we multiply it out, what we'll get is a 4a squared x squared in front. So what we need to do is divide throughout. All right, so we've got an equation we can multiply throughout by 1 over 4a, all right, because 1 over 4a times 4a squared is exactly a. All right, so here we have the expression factorized. All right, now you can also use that to get the get the quadratic formula that we found above. Okay, you can use this factorization to do that. All right, now let's just think of an example. All right, so let's see if I can find one. Now, you know what, I will do this by expansion, so I'm going to go on my other screen and find one in secret. All right, so I'll think of 1, 3. Okay, I shouldn't speak aloud there. And then I'm just expanding the expression so that I can talk to you about factorizing it. Okay, so I've got one. And now I can get rid of my expansion. Cut. And I can move this back over and show you what I have. All right, so I'll reverse this. First. Okay, so here is the expression that we wish to factorize by hand. All right, so now sometimes you can do this thinking about it, right? So you might consider, what are the divisors of 6? What are the divisors of 56, and so on. Well, we can talk about that next. All right, but how do you do this with the quadratic formula? All right, so well, we would have, let's just supply this into our formula. Now we have got a equals 6, b equals -5, and c equals -56. Okay, so solving. All right, first of all, we're solving this, right? Okay, so solving using quadratic formula. All right, so we say a is 6, b is -5, and c is -56. All right, again, I'm just writing. I don't intend to execute this as Mathematica commands. All right, so what's the formula say? X is negative b plus or minus the square root of the discriminant b squared minus 4ac, and then this is all over 2a, and I need to put the brackets around this. All right, so that's what the formula says. Now if I substitute these values in, well, let's do that and then simplify. Okay, -5 is +5, all right? 5 squared is 25. Now 4 times a is 4 times 6, and then we must then multiply that by -56. Right, and a was 6. Okay, so this is the expression that we need to simplify in order to solve for x. All right, so I'll do this simplification by hand. Actually, you know what? I'll just copy this into a new cell, and I'll get Mathematica to do that hard work. All right, -8/3. So let's just suppose that we had done that simplification by hand, but we got some help. Okay, so we have this, right? Now, how does that tell us? Is that right? Why did we only get 1? Oh, I see. Because we did plus or minus, so it really interpreted that as minus. So I'll do that. So we've got 7/2, and then the other one is probably -8/3. Yep. Okay, so we'll write or this. So we should write x equals that, or x equals 7/2. All right, so now let's treat these as two linear equations. So the first one, I will multiply both sides by 3 and get 3x, and then I'll add the 8 to both sides, so +8 is 0, or 2x minus 7 is 0. All right, so what I'm doing is using the quadratic formula to help you to factorize a quadratic expression. All right, so what we find is that, well, we must have 3x plus 8 times 2x minus 7 has to be 0, right? Now let's just double check that with Mathematica. Copy and paste, and I'll write expand. Well, look, you get 6x squared minus 5x minus 56, so that's correct. That gives you a formula for the factorization by using quadratic formula. You just have to do a little bit more algebraic work at the end. Okay, so that's using the quadratic formula to do it. Now let's consider doing the factorization using a method that most of us get taught initially. All right, so where do I want to put this? So let's write alternatively. All right, so this is the way many of us learn to do this. So we have this. What we look for first is the divisors, okay? So, well, we've got a square in x, all right? This is a quadratic expression in x. So first you might want to put an x there, plus something, another bracket. So we know already what the form should look like, right? Plus something like this, where this is a number, this is a number. We're gonna have a coefficient there and a coefficient there. Okay, so you ask yourself, what are the divisors of 6? Well, we've got 1, we've got 6, we've got 2, we've got 3. You know what? I'm going to get some help here. I reckon that there's probably a built-in function for this, maybe called divisors. Yep, divisors. 6, let's have a look. 1, 2, 3, and 6. Okay, now keep in mind that factorization, other than trial division, involves some pretty sophisticated techniques. Trial division is notoriously slow at finding the factors, so this method is only useful where the numbers are relatively small. Okay, if you've got a 500-digit number, well, you don't want to do this. You don't want to seek out factors of that number because it will take forever. All right, so what are the divisors? Now these can be possibilities. We have 1 with 6, 2 with 3. So what you do in this method is you try out the possibilities. Okay, so we say 1 could go there, 6 could go there, and then likewise we seek out the divisors of 56. Okay, so I'll write that in a new line, divisors of 56. Well, there are many more of those, right? So lots of possibilities. All right, next, once you choose a pair of divisors that multiply together to be 56, well, then you've got to combine these in such a way that you get a sum or a difference equal to 5. All right, so this will take quite a lot of trial and error often, and some people like to put this in a table. Okay, so this, if you're using this method, it takes a fair bit of experience in doing it because it's not always easy, right? Okay, so let's see if I can do this. Now, hey, I should have remembered. Well, hey, you know what? We've got it right up here. So 7 and 8 are the answers here. 7 and 8, right? But there's a lot of trial and error to get that. And also 2 and 3 are the appropriate divisors of 6. Okay? So that's basically the method. You seek out pairs of divisors of the two numbers on the end. You put them together, trying possibilities until they add or subtract to be the number in the middle, which is in our case the minus 5. All right, so we put in 3, we put in 2, put in 8, we put in 7, and now we are thinking of 3 times 7 and 8 by 2. All right, 3 times 7 is 21, 8 times 2 is 16, so their difference is 5. All right, now we've got to work out where the signs go. All right, because 56 minus 56 is negative, so one of these has to be negative. Now if I put it here, what happens is I get plus 21 minus 16, which is plus 5, so I don't want it there. All right, so I'll put plus there. The minus has to go here. All right, so that's how to perform the factorization using trial division, right? Which is the way that most of you learn factorization of quadratic polynomials at first. Okay, so let's have a look and see if I have anything more to say on quadratic polynomials and their factorization. So here are some more examples in my booklet. Some more examples, and then the quadratic formula, and that's basically all that we have considered. Oh, I should say, look down here. Sometimes you might consider the roots or the zeros of the polynomial. Often we use alpha to describe those. So you have an alpha 1 and an alpha 2. These are the numbers that make that polynomial, in our case a quadratic, the numbers that make that polynomial 0 when we substitute those in. Okay, so I'll just give you a Mathematica example of that. So let's see. Look, I'm going to go and pull this up first of all, and I'll show you another way to do this. All right, so Mathematica has a built-in function to do this. It's called solve. So solve, and we only have one variable, x. So if we just press solve this equals 0, we'll get the two answers, you see? And that's really easy. It's really easy to check what you're doing by hand when you're learning. All right, so now these numbers that we found, they are called the zeros of the polynomial. This is a polynomial right here. Or the roots of the polynomial, or the roots of the function. Those all mean roughly the same thing. Okay, now what I want to do is I want to take this polynomial expression, take it, I'll paste it there, and I'm going to right now replace all. I like this built-in function because I don't have to enter things into memory to use it, right? I can just sub in. Right, so for example, I do this, and so what that means is substitute in minus 8/3 and get the answer. All right, now how do you make this? I'll just get rid of this, so I'll show you how to make it. Right, you put in the minus sign and then the greater than sign, and then you press the space bar, and it turns into an arrow. Okay, let's press Shift Enter. Now you see we get 0. All right, that means that this, what we call a 0 or root of this polynomial. All right, it makes it 0. Okay, so what about 7/2? 7/2. Okay, that should also be 0, 0. Okay, so we'll call this alpha 1 and alpha 2 are the roots. Now, what if you wanted to write an alpha in Mathematica? Well, you would go up to the palettes, Basic Math Assistant, and I'll show it to you. It looks like this. Now, let's see, how do we get the letters? The button is right here. Okay, and then an alpha is right there, so I can press that button and an alpha will appear. Okay, it's appeared there where my cursor was. Now what if I want an alpha subscript? Okay, so I'll go for the subscript. Right here I see a subscript button. All right, that gives two little places for me to input something. So I'll put that alpha right there. And then in the bottom, I'll put a 1. All right, now I can get rid of the palette and use copy and paste to get this. Okay, so we have alpha 1 was minus 8/3. And then alpha 2 is 7/2. All right, so this is what we have. Now look, we can assign these values. So I'll put equals rather than equals. Equals, okay, semicolon, semicolon. Okay, now let's say, just to show you, 6 alpha 1 squared minus 5 alpha 1 minus 56. Because I put that in memory, this should also be 0. Yes, okay, so I'll put a semicolon there, so we'll only get 1 0. Yeah, 0 for this one, the one I didn't have a semicolon on. Okay, so I hope you learned something. That's about all I have to say for now. So we learned about factorization, quadratic polynomials and their factorization, and the quadratic formula. So that was quite a lot of things to learn in this session. Okay, have a look at one of my other videos. You can see things like this, elementary stuff, intermediate things, and fun videos and so on. Okay, bye for now.